All right, pre-cal, here we go on Unit 2. This is your third page of notes. We're going to talk about zeros, we're going to talk about multiplicity, turning points, and graphing. Okay, so the graphing, actually, this will probably be in another video because it takes some time to explain. All right, so the first thing we're going to do is talk about solutions of a polynomial equation. Remember that all of your solutions, okay, we've got zeros, x-intercepts, roots, solutions. They all pretty much mean the same thing. They are all points of the graph that cross or touch the x-axis. And sometimes when we talk about it just touching the x-axis, we also use the word it just bounces off of the x-axis, like if it looks something like this. All right, so see, it kind of bounces right there, just bounces on there. All right, so the difference between a solution, a zero, and a factor. This is something that students really struggle with because it's a vocabulary thing, you know. So let's say we had a solution of x equals 5 and x equals 3. So in other words, I have a graph that crosses the x-axis at 5, and I have the same graph crosses at x equals 3. So these right here would be solutions, and if we write them as zeros, then it just looks like this, okay? Because they're x-intercepts. So we can write them as ordered pairs where y is equal to 0. And then a factor would look like this. X minus 5 times x minus 3. So these are factors. Hopefully you see the difference between all of these. The solutions actually come from the factors. So if you'll look at this, if I were to set each of these factors equal to 0 and solve, I would get x equals 5, x equals 3. Magic. All right, so if you'll look at the two examples we have down here, I've got this graph, and I'm going to list the x-intercepts. So I'm going to list the zeros. So right here, we've got one that's at -2, 0. And we've got one here at the origin, that's 0, 0. And then right here, that's +2, 0. We're going to do the same thing over here for this graph. I've got 4 solutions here. So I've got -2, 0, -1, 0, +1, 0, and 2, 0. All right, so let's look at this idea, this concept of multiplicity. What does that mean? Well, multiplicity occurs when you have repeated values as solutions. So what does that look like? Well, let's say I had a parabola that had the same exact factors, all right? So if this is the case, that means I have two solutions, because when I set each of these equal to 0, oops, I'm losing control, and solve them, I get the same thing for both of them. So x equals -3. Well, this has got a multiplicity of 2. What does that mean? That means that your graph sits or bounces at -3. So anytime you have multiplicity, that is where your graph touches the x-axis or sits on it. You can also think of it bouncing off of the x-axis. All right, so what would it look like graphically, and how would we write it? Well, as you can see in this graph I've given you, okay, we have a solution right here, and right here, and right here. So this solution over here would be -3, 0. And then at the origin, since it's sitting at the origin, that means we've got a multiplicity of 2. And then we've also got an ordered pair at 3, 0. So this has 4 solutions, and I'm going to show you in just a minute how we can tell it's got 4 solutions. All right, so what will the degree of the polynomial tell you about? So thinking back to what we did on the first 2 pages of our notes, remember that our degree gives us an idea about our end behavior. So it helps with that. But it also tells me some other things. My degree tells me how many zeros or x-intercepts or roots or solutions, how many times it crosses or touches the x-axis. So if I've got a degree of 7, there are 7 solutions. All right, it also tells me how many turns the graph has. Be careful. Be careful, babies. A polynomial, when you graph it, does not have as many turns as it has degree. It's got 1 less turn. Okay, so if I've got a polynomial with a degree of 6, there are 5 turns. All right, just as an example. All right, along with the leading coefficient, if you'll recall, it indicates to us the end behavior, and we've already talked about that. So in the next video, we're going to do something really fun. We're going to graph these crazy looking polynomials without a calculator. What?